Welcome, my name is Troy Roach. I'm a patient turned researcher, and today I'm going to bring you the third installment of our Smidgen of Science videos. This one related to the benefits of using nicotine patches before or after an acute infection. Are you ready? Let's go. Our third talk on transdermal slow-dose nicotine treatments is going to focus on this article from Nature.com. This was published about a year or year and a half ago. It is a study done on mice, so this is not a study done on humans. Nicotine exposure decreases the likelihood of SARS, RNA expression, and neuropathology in ACE2 mouse brains, but it does not prevent death. The little abstract, they basically say that, well, first of all, it's widely known in the scientific community and anybody with LongCovid that SARS-CoV-2 causes brain damage, right? So this is already an accepted fact. Next, the main results of the study show that nicotine reduces SARS RNA in the brain and also reduces brain damage. So on to the details. Here they give some details about the different types of damage that can happen to the brain, a long list of neurological damage that is common in long COVID patients. Even in mild cases of COVID-19, it has been shown that there's structural damage to the brain. There's a very large study on this. And there's also an increased risk of Alzheimer's disease after a COVID-19 infection. As always, a reminder, this has nothing to do with smoking or any other type of nicotine. This is only low-dose transdermal nicotine using the nicotine patch. On to the next part. This study was done on a group of 64 mice. They were divided into 4 groups. There's the control group, the group that was given SARS but no nicotine. Then there was a group that was given nicotine but only after being infected with SARS, and then a group that was given nicotine starting 4 weeks before the actual infection and then continuing during the actual infection. And then you can see from the image that they took half of the brain of the mouse to detect the viral RNA, and they took the other half of the brain in order to do histopathology, in order to see the actual damage and what kind of brain damage was done into the mice and how it differs between the different groups. This is also another reason why this type of study is better to do on mice, because not many people would volunteer for this kind of study. On to the first results. The survival between the groups was similar. That's why they say in the results that it does not help protect against death. When they took one half of the brain to look for viral RNA, then the group that was using nicotine before and after the acute infection, they were more than 3 times less likely to have viral RNA. If you compared the groups that just had the nicotine after infection with the ones that didn't get any nicotine, then they were almost twice as less likely to have viral debris in the brain. That means that it's best to start using nicotine patches before you have an infection to prevent against damage that could lead to long COVID or Alzheimer's. The graph, which shows the same information just talked about, you see here the control group is in red, and so they don't have RNA expression. And then the purple one on the far right, most of them were more similar to the control group in not having RNA expression. This is a visual representation of how much virus is getting into the brain. Connecting to the next section of results, here they're talking about the endothelial layer and how the endothelial layer on the blood-brain barrier is very important pathology. So the more virus that gets through the blood-brain barrier, the more damage you're going to have, and that these results are correlating. They go through a long list of different regions of the brain where they found and where they found lesions in the brain. Of note, I think the hippocampus, thalamus, hypothalamus, amygdala, and the brainstem are very important for us, especially the brainstem for long COVID. And then the virus crossed into the brain, then inside the brain you have microglia and astrocytes, which are protecting the brain. But while they're protecting the brain, they're also destroying parts of the brain. And between microglia and astrocytes, most of the damage they saw done was done by microglia. So it's very important effect on microglia in the brain. In conclusion, the results of this study indicate that nicotine exposure prior to a SARS-CoV-2 infection reduced the likelihood of SARS-CoV-2 RNA expression and the related neuropathology in the brain, but not death. The next part of the discussion, they move on to the part about their hypothesis of what is going on in the brain. I personally don't agree with their hypothesis. They say that there are nicotinic receptors in many types of cells and tissues, for example, in the microglia, neurons, and the epithelium of the airways and the blood-brain barrier. Hypothesized that chronic binding of the nicotine to the nicotinic receptors on the epithelial cells and microglia might desensitize nicotinic receptors, leading to a suppressed hyperimmune response during the SARS-related cytokine storm, maintaining the blood-brain barrier integrity. For me, this doesn't follow the correct logical path of what would happen first, second, third, etc. It will take time to find out what that answer is. And they go on to mention things like past studies in the lab show that SARS binds to the A7 nicotinic acetylcholine receptors. Finally, the authors in their discussion go over a few points which I think are relevant. In future studies, it would be interesting to see how long before infection people need to be taking nicotine. Here, the mice started taking nicotine a month before. What if we did a lot of groups of 15 days, 10 days, 2 days, 1 day, to see really how long before an infection a person needs to start with the nicotine patch in order to get the maximum protection against a SARS-CoV-2 infection. And they talk about the fact that the mice died in equal numbers amongst the groups, and that should have done a 5-day endpoint so that when they were evaluating the mice, they would have had a larger cohort to look at and compare. But that's the way the study was designed, a 7-day stopping point. In conclusion, the last sentence is the fact that it can decrease the likelihood of SARS-CoV-2 neural invasion and the associated pathologies indicate that nicotine could be leveraged to prevent and mitigate a lot of damage done by this virus. And that, folks, is why I personally still continue to use the nicotine patch on a fairly regular basis. Even though I've probably maximized my benefits for long COVID, I still use the nicotine patch on a regular basis because if I do get infected in the future, I want to reduce any further damage done in the brain. Hopefully, this will give you some hope in the future. Good luck. Believe it or not, I'm human and I can make mistakes. And this smidge or tidbit of science is far from complete. Comment below with your suggestions or corrections. Let the conversation begin. We are stronger together. Take care of yourself, and if you can, take care of someone else. See you soon.